Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina wa Maulana Muhammadin wa ala alihi wa sallim. Allahumma rabbi zidni ilma. Allahumma rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina adhaban nar. Ameen. Allahumma salli ala Sayyidina wa Maulana Muhammadin wa ala alihi wa sallim. Alhamdulillahi rabbil alameen. Conditional probability examples. Learn and spread knowledge. This is question number 4 of June 20, paper 63. Part A. The random variable A has the Poisson distribution with mean 1.5. A1 and A2 are independent values of A. Find this probability A1 plus A2 less than 2. First we need lambda of A1 plus A2. So it should be 1.5 plus 1.5, that is 3. So lambda is 3. Now we need this probability A1 plus A2 less than 2. So less than 2 means these are the possible values of A1 plus A2, 0 or 1. Generally less than 2 means probability of 0 or 1. So e power minus 3, for 0 we write 1, and for 1 we write 3 power 1 over 1 factorial. Therefore, the final answer up to 3 significant figures is 0.199. Now this is the conditional probability part of this question. Given that A1 plus A2 is less than 2, find this probability. Now this is the formula of conditional probability. We need this probability A1 is 1 and A1 plus A2 less than 2. So their intersection must be in numerator and the given information must be in denominator. This is the formula of conditional probability. The intersection of these two must be in numerator and this given information must be in denominator. You can also write, instead of and you can write this symbol, intersection. Intersection and they both means the same thing. Now we have to understand this intersection thing carefully. And this is the most important part of conditional probability. This is an important note. See, A1 plus A2 is less than 2 with A1 is 1. So we have to decide the values of A2. We have to decide the values of this because this is fixed. This is 1. So when this is 1, then A2 must be 0 in order to satisfy this inequality, less than 2. Therefore, this means we need probability A2 is 0 here. So this means probability A2 is 0. Now we have to copy this formula. So probability A1 is 1. Here we had A1 plus A2 less than 0. See, we had this information. So instead of this information, you have to write A2 is equal to 0. And denominator is as it is. A1 plus A2 is less than 2. You can check the solution as a whole. See, first write this formula according to the given information. Now understand the meaning of these two. You need intersection of these two. So you have to understand this thing very carefully. You have to decide the value of A2 carefully. A1 is 1. This is here. This is fixed. So decide the value of A2 so that this inequality will be verified. So when A2 is 0, this inequality is verifying. So A1 is 1 and A2 is 0. So this is here, and instead of this, you have to write probability A2 is equal to 0. Now after that, you need to just substitute the values of the probabilities here. So probability A1 is 1 is e power minus 1.5 into 1.5 power 1. This is here. And A2 0 means probability E minus 1.5. And this is the answer of part 1. This was 0.199, but we need exact value of this. We need the exact value of this. So I'm writing 0.199 dot dot. You have to put at least 4 decimal place value here. Hence the final answer is 0.375 up to 3 significant figures. So this is the way to solve conditional probability questions in S2. Well, the last part of this question, give a reason why A1 minus A2 cannot have a Poisson distribution, because it takes negative values. And Poisson variable can't take negative values. The second example of conditional probability question in S2. Question number 4. This question is from June 18 of paper 73. Well, the first part of this question. The numbers M and F of male and female students who leave a particular school each year to study engineering have means 3.1 and 0.8. This is for males and this is for females. State in context one condition required for M to have a Poisson distribution. The mean should be constant. You can write this as number of males leaving to do engineering each year has constant mean. Assume that M and F can be modeled by independent Poisson distributions. Part 2. Find the probability that the total number of students who leave to study engineering in a particular year is more than 3. So total means we have to add lambda of both. So 3.1 plus 0.8 is 3.9, and we need more than 3. So total m plus f is greater than 3. So this means 4, 5, 6. This method is not applicable in Poisson because Poisson is infinite. So the answer should be 0, 1, 2, 3, 1 minus. So 1 minus e power minus 3.9. For 0 we always write 1. For 1 we always write 3 point lambda power 1 over 1 factorial. 2 means lambda power 2 over 2 factorial. 3 means lambda cube over 3 factorial. First write the exact value, the more accurate value, because this value will be used in the later part. And then write 3 significant value, which is 0.547. This is the answer of this part, but we will use this value in the later part, the more accurate value. Now this is the conditional probability part. Because of this statement given that the total number of students who leave to study engineering in a particular year is more than 3. So this is the denominator of this part 3. M plus F greater than 3, and this answer is 0.546753. Find the probability that no female students leave to study. So here we have F0 to study engineering in that year. So we need this thing. See, probability no female intersection m plus f greater than 3. This is the way to write the formula of conditional probability in S2. This is the intersection part. I did the same thing in this question. See, this is here and this given information is here and the result of this is here. Same thing is here. This is the requirement, no female students, so this should be here. The given information more than 3 is here, and means intersection of these two. And this, the total of this is here. I mean, the answer of part 1 is here. Now we have to understand these two in detail and very carefully. So, n plus f greater than 3 with f0. Decide the value of m with f0. So m should be 3 plus 0, or you can say m should be 4 plus 0. 4 is greater than 3. So we need this probability, m greater equal to 4 here. You have both the options. You can also write m plus f greater than 3 is 3 plus 0 greater than 3. So when you will write m3, then this 3 is exclusive. this should be greater than 3. When you will write 4 here, then you have to read this as this value is inclusive. Here this value is exclusive. So I think this is the easier way. Now we have to write this here. So probability F0 and probability M greater equal to 4 divided by 0.546753. Probability F0, this is very simple, e power minus 0.8, and probability M greater equal to 4 means 1 minus 0, 1, 2 or 3. So e power minus 0.8, 1 minus e power minus 3.1, 1, 3.1, 3.1 square over 2 factorial, 3.1 cube over 3 factorial divided by 0.546753. Hence, the final answer up to 3 significant figures is 0.308. You must understand these two steps, this and this. First, write the formula correctly and then decide the value of M and then write this here. And give your answer up to 3 significant figures. Last example of conditional probability. The independent random variables x and y have the Poisson distributions. Find x plus y is 3. This is very simple. We just need to add lambda of both. So lambda is 2.1 plus 3.5, which is 5.6. X plus y is equal to 3 means exactly 3. 5.6 cube over 3 factorial. So the answer is 1.108, 3 significant figures. Now this is the conditional probability. Again, write the formula carefully. Write the requirement here, x2 and x plus y is equal to 3. This is the given information, and write this given information here, which is the answer of part 1. Here first give accurate value, which is 0.108234, because this value will be used in the later part, and this is the estimated value. This is the answer of the part 1. So now understand this thing carefully. Decide the value of y. X plus y is 3, and with y, with x2, write this here and this here. Now decide the value of y. Because x is fixed, it is 2. So y should be 1. When y is 1, then this equation is verified. So we need probability y1 here. So the conditional probability formula will be probability x2 times probability y1 divided by 0.108234. Probability x2 is very simple. This is e power minus 2.1 power 2 over 2 factorial. Probability y1 is also very simple. This is e power minus 3.5 power 1 over 1 factorial. Divided by 0.108234. Hence, the final answer correct to 3 significant figures is 0.264. I hope this lecture will help you to understand conditional probability in S2.